Hello students, we have been discussing about the chapter arithmetic progression. Here today in this class we will discuss about few more applications of Sn formula, which we may write it as n by 2 into 2a plus n minus 1 to d, or else we can write it as Sn equals to n by 2 into a plus an. So let us take some example. Here this is one question from NCERT exercise 5.3 question number 4. It's given how many terms of the AP is given, must be taken to give the sum of 636. So here the AP is given, it means A is given, which is 9, D we can find, which is 17 minus 9, and Sn is also given, which is 636. Now using this information we will have to find the number of terms. That means we have to find the value of n. So here we have used Sn formula. Sn is given, so we have started with this. Sn equal to 636, which is n by 2, 2a plus n minus 1 into d equals to 636. We have put the value of a, which is 9, we have put the value of d, which is 8, and simplified. Here we have simplified. Then from this step we have taken 2 common. This 2 is outside, and from 8 we have taken 2 outside, so 4 left. And then after that 4 is multiplied with n, 4n, and then 4 into minus 1 minus 4. So this is simplified to 9 minus 4 5 plus 4n, and then we have multiplied. Now here we have to solve this by using factorization. So with n square we have 4, and this is 636. So first of all let us factorize 636. So if we factorize we will get 3 into 4 into 53. Then as we have 4 with n square, this 4 will have to multiply with 636 while splitting this 5. So 4 into 636, that means 4 into this 12 into 53. And now from these two part, 4 12 are 48 and 53. 53 minus 48 is 5, and 53 into 48 will be this number. So instead of 5 we can take 53 minus 48, that we have written here, and then we have split the middle term 5 and factorize. That here from we have got one this part and second part, so product of these two is 0. It means either first part is 0 or n minus 12 is 0. So here from shifting 53 minus 53 and then 4 divide, it is minus 53 by 4, which is not possible because value of n, it indicates the position, which cannot be negative or it cannot be fraction, so it is not possible. From the second part, n minus 12 equal to 0, we can get n equals to 12. So therefore the number of term is 12. Next sum is question number 8. Here you have to find the sum of first 51 terms of an AP whose second and third terms are given 14 and 18. The AP is not given, but second term is given 14 and third term is given 18. And of course value of n is given, which is 51. So from here we will have to find Sn. So to get Sn, obviously we have to find two things. One is A and another is the common difference, that is D. Now here A2 is 14 and A3 is 18. As they are consecutive terms, that means serial term A2 and then next A3, so we can get D. D will be A3 minus A2, third term minus second term, which is 4. Now after getting D, this we can use here. a2 means a plus 2 minus 1 into d. An formula equals to 14. So a plus 1d equal to 14. So a value is 10 by putting the value of d, which is 4. So simplifying, that is 10. Now d we have got 4 and then a we have got 10. So now using these a and d, here we can find the value of S51. So we have used this Sn formula, n by 2, 2a plus n minus 1 into d. So let us put the value. A is 10, then d is 4. So 54, 200, 20, 220 and 51 by 2. 2 cancel 220, so it becomes 110, and 51 multiplied with 110, that is 5610, and that is the answer. That means sum of first 51 terms is 5610. Next sum is question number 9. Here the sum of first 7 terms of the AP is given 49, and sum of 17 terms is given 289. From there we have to find the sum of first n terms. So finally n is not given in Sn, but in first two cases, here n is given 7 for n equal to 7, Sn is 49, and for n equal to 17, Sn is 289. Now using these two conditions, we have to find Sn where n is not given. So S17 is 49 is given, S7 is 49 and S17 is 289. So S7, it means 7 by 2, 2a plus 7 minus 1 into d is 49, and here 17 by 2 into 2a plus 17 minus 1 into d, which is 289. So this is second equation. Simplifying, 2a plus 16d, this 17 by 2 shifted right side, 289 into 2, this 2 will come up and 17 will go down. So simplifying, we will get 17 into 2, because 289, if we cancel by 17, 17 left. So 17 into 2, 34. So this is one equation, and here also in the same way simplifying, we will get first equation. Now using elimination method, this first equation and second equation we have to solve. So here, as the coefficient of a in both equation are same, 2, directly we have subtract equation 1 from 2. So equation 2 minus 1, 2a minus 2a cancel out, 16d minus 6d, 10d left, and right side 34 minus 14, 20 left. So here from we can get d, which is 2. Now putting the value of d in equation 1, I can get 2a plus 6d equals to 14. So 2a plus 6 into d means 2, that we have got here. So 12, this 12 shift right side, 2 left, so then a is 1. Now using the value of a and d, a is 1, d is 2, we will have to find Sn, which is n by 2, 2a plus n minus 1 into d, where n is not given. So put the value of a and d in the formula. So a is 1 and d is 2. So 2 ones are 2, and from here this step, both this 2 and this 2 taken outside common. So here 1 left plus n minus 1 left. So then this 2 is cancelled out, only n left outside. Here 1 plus n minus 1. So minus 1 plus 1 will cancel, only n will left inside. So n into n square. So therefore, as per the question, we had to find the sum of first n terms, and the answer is n square. Our next question is question number 10, where we have to show that a1, a2, a3 dot an form an AP where a is given as 3 plus 4n. So this is an equals to 3 plus 4n. Now using this an, we'll have to find the value of a1, a2, a3 and so on, and then later on we have to verify whether these numbers form AP or not. So for this, first of all, using this an, a1 we will find. So a1 means value of n is 1, that is equals to 3 plus 4 into 1, so that is 7. Then a2, 3 plus 4 into 2, in place of n we have put 2, that is 11. a3 will be again 3 plus 4 into 3, that is 15. Now we have got 3 terms, so let us verify the difference between each consecutive terms. So first a2 minus a1, that is 11 minus 7, 4, and secondly a3 minus a2, that is 15 minus 11, that is also 4. So as you can see, the difference between each consecutive terms are equal. So thus we can tell that the terms of this sequence an equal to 3 plus 4n forms an AP. Now one more part is given in the question. Also we have to find the sum of first 15 terms. So now the terms forms AP, so you can use SN formula of AP. Here a1 means a, that is 7, and d is second term minus first term, that is 4. So a and d we have written here, and then this a and d value we have put in the SN formula, where n is 15, because we have to find the sum of first 15 terms, that means n is 15. So putting the value of n and other value of a and d, simplifying, we can get the value of Sn is 525. In question number 11, where Sn is given 4n minus n square. Here what is the first term? That means we have to find a. Next, what is the sum of first two terms? That means we have to find S2. Next, what is the second term? That means we have to find A2. Similarly, we have to find third term, 10th term, and then finally nth term. So to do this, Sn is given, which is 4n minus n square. Now if we find S1, that is 4 into 1 minus 1 square. So 4 minus 1, which is 3. S1 means sum up to first term. It means up to first term, starting from first term and up to first term. It is only the first term, A1, which is equals to 3. Now let us come to S2, that is 4n minus n square. So in place of n we will put 2, 4 into 2 minus 2 square. So simplifying we will get 4. Now S2 means sum up to second term, that means first term plus second term. So A1 first term already we have got, that is 3. Put it here, so then we can get A2, which is 4 and minus 3, which is 1, that is second term. Now let us see one relation, S2 minus S1. It is actually what? S2 means A1 plus A2, sum of first two terms, and S1 means only the first term. So if we subtract S1 from S2, then A1 will cancel, only A2 will left. So S2 minus S1 is A2, therefore A2 we can find in this way also. Here we have got in this way, and we can get in this way also, that is S2 minus S1, which is also the same. A2 is 1, A2 is 1. Now let us find S3. S3 is again 4 into 3 minus 3 square that we have written here, which is 12 minus 9, so 3. So in place of S3 we can write A1 plus A2 plus A3, because S3 means sum up to third term. So then this we have written, and right side it is 3 that we have written. Now A1 and A2 value we have already got, that we have put here. So A3 is 3 minus this 4, that is minus 1. Now let us see the another way. S3 minus S2, it is A1 plus A2 plus A3, and S2 means A1 plus A2. So if we subtract, only A3 left. So if we need to find A3 from this, we can find in this way, or else A3 means directly we can get S3 minus S2 also. So that is 3 minus 4 minus 1. So answer would be same however we find. But if we compare this relation and this relation, we can come to one conclusion, that A2 means S2 minus S1 and A3 means S3 minus S2. Similarly, A10 can be S10 minus S9 using the earlier relation. So S10 value we can get from the given condition Sn. So 4 into n minus n square, so 4 into 10 minus 10 square, that is minus 60. Then similarly S9 is 4 into 9 minus 9 square, that is minus 45. Now these two value directly we can put here and simplify to get A10, which is minus 15. So this we can remember as one relation, and that I have written in general. For any nth term is Sn is given, any nth term will be An equals to Sn minus Sn minus 1. Like here we have to find A10, A10 will be S10 minus S10 minus 1, which is 9. So this relation only we have written here as general formula, An equal to Sn minus Sn minus 1. Now Sn is given in the question, 4n minus n square minus Sn minus 1. It means in place of this n, we'll have to write n minus 1. So 4 into n minus 1 minus n minus 1 square, that I have written here in this place. And then 4 into n minus 4 minus this a minus b whole square, we have broken a square minus 2ab plus b square. So this is the part, and then breaking the bracket, it becomes minus n square. This minus minus will be plus, and plus minus will be minus. So simplifying, 4n plus 2n is 6n, minus 4 minus 1 is minus 5, and minus n square. In next step, removing this bracket, all the sign will change. So this will become minus, this will become plus 5, and minus n square. It will become this plus, because this minus and minus will be plus. So this plus n square and minus n square will cancel out. 4n minus 6n is minus 2n, and this plus 5 left. So therefore value of an will be 5 minus 2n, and this is the final answer. Let us see one more sum, that is question number 13. Find the sum of the first 15 multiples of 8. Multiples of 8 means it can be 8, 16, 24, 32, and first 15 means we have to start from 8. So we can form AP, because the difference are all equal. So the AP is 8, 16, 24 up to 15 terms, because we have to find the sum of first 15 multiples. So n will be 15. So D is 16 minus 8, that is 8, and A is obviously 8, the first term. Now Sn, using Sn formula, n by 2 2a plus n minus 1 into D. The value of A is 8, n is 15, D is 8, here n is 15. So 15 by 2, 2 8 is 16 plus 15 minus 1 is 14 into 8, 112, and plus 16, 128. So this 128 we can cancel by 2, 64 will left, multiplying with 15, so 960 will be the answer. So these are some examples where we have used the SN formula. So we have to do more sum to clarify this application of SN formula. Thank you.